Today we're going to see this example that you see on the screen as a simple mechanical system. Well, perhaps not very extremely simple, not either, but because this one has a couple of masses and several elements in there. But the objective here is to establish a procedure that we will use to generate a bone graft model and not make mistakes. So let's take a look at step by step. You see the example in there has this part that represents the wall over here, floor here. You have this card and it has this mass connected to this other one. So I am gonna we're gonna call it I1 over here, and then to this one we're gonna call it I2 here. So the very first thing that we do is that we have to recognize what elements we have. So why don't we call it steps, and step number one is going to be to recognize the elements in the system. And so do we have the element R, the I element, we have the C, whatever we have. In this case, we could even name them if we choose. But here is you have a C and an R over here. We're going to do the determination here that this would be, this one's connected, it's going to be C2 and an R2 here, and we're going to call this a C1 and an R1. How is that? I think that way we know where we are situated and what belongs to what. So we have them as step number two. Step number one. Step number two is going to be to use a one junction for each distinct velocity. Very good. So what I will do is I'm gonna go here and say change pens in here, and we could establish that the motion this way of this is I2, so we're gonna call it x of 2, and then this one over here we're going to call it x of 1. Yeah, so x of 2 dot and x of 1 dot will have the same direction. So what are we going to do? We'll just say, okay, this is a 1 in here that represents x1 dot, and we have the other one over here that represents the x2 dot. Yeah, so but are we done with the velocities? Not really, because this one here, this wall, has also a velocity 0 and is our reference. So I would suggest that we do that. We put 1, the velocity v is equal to 0. But it gets into the system itself. So in here we have a we don't have an external force, but if we did, we could put it in here. system can get started with initial conditions like the one in your lab. But this is we did step number 2. Now we need to go to step number 3. What is step number 3 going to be? Huh? So 3, we are going to say attach the elements that move at those velocities. Okay, very good. So this it's very obvious that one of the elements that move at the velocity is going to be the in this case this I2 the car. So this is going to be an I2 element. And then you have that this moves at x1 dot. So yeah, so this is the second one. And I would attach in here a source of flow with velocity equals to 0. Yeah, so these are the elements on step number 3. So we have the wall in here, we have this distinct velocity, we have this other one. So we are done with the step number 3. What would be a step number 4? Let's just write it in here. In here you have step number 4. We are going to use zero junctions to represent the differences So between between these two velocities, we can say, okay, this is a 0, and I am going to say this minus that is this velocity in here is x sub 2 dot minus x1 dot. Yeah. See, this is the difference between this and this. Okay. So use zero junctions to represent the velocity difference. So this is the one here, which is x2 minus x1, this one. And in between these two also, we will have, how do we do it? We have that x2 moves, or that, yeah, that's what it is, because the wall does not. So this one in here is the value of this. So it makes sense to have this. In here you see we have created the differences, and that also represented by ones. So use zero junction to represent the different velocity. And then you could say you say those differences are also represented by 1 junctions. What do I mean with this? Say you had this 0, which represents the 0 represents this minus this, but the difference is also a 1, you know, that difference. In this case, we have this minus this, the result is this. Okay, very good. You see we have 4 steps, 4 very important steps. Number 5, which we can write it in here, we're going to say attach the elements that experience those differences. Okay. There we go. So attach the elements that experience those differences. Can we do that right now? Take a look here. Between this and this, you have these elements that experience the difference between this velocity and that one. And that's this C element, whose parameter is C1, and this one, this R element, whose parameter in this case is R1. Okay, and then you have the difference between this and the wall. The difference between this and the wall is expressed over here, and attached to that, the other mass is moving with that. See, and so in here we're gonna put this one here, the difference between this and this. So this is gonna be an I element with I2 as a parameter, and this one is going to be a, yep, this is going to be the, excuse me, I think we have a small mistake here. It's just erases. The elements that experience this difference between this and this is the C and the R. So that's what we need to correct over here, that this is a C element with value C sub 2. And this is an R element with value or physical parameter value R sub 1. Wow. You see, all of a sudden with this step, with these simple steps and just 4 or 5 lines of explanation, we have created the model of this entire system. And then you could say number 6, which I would see attach those velocity, those differences, and you can say here at this point, the model can be entered in CAMG. All right, but you see, you could do a set of what I would call optional. See, what's the number 6? Call it 6 is going to be like an optional step, because we have performed what the most we could do here is to enter it into the bond graph model itself. But seeing here, I mean, we could do other things. We could simplify. We could check the causal marks. Yeah, you check all the things. Not simplify, but simplify. This is, I would say, these are almost optional steps, because you, with this, you should be able to enter it into the CAMG software. Now you can do simplifications to this bond graph, but you don't really have to. In fact, what I would do is to demonstrate and illustrate this. Let's just enter it into the CAMG software. So to do that, maybe we'll to minimize this a little bit in here. All I want to keep available is the pictures, so that we can guide ourselves what to do. Okay, there we go. So I'll just use that's the bond graph model here, and I could use the CAMG software right now. Say on programs, go to the CAMG here, over here, right there, and then we're going to get started and enter this bond graph into the software and see what it does. And that be, let's see, file new, we need to do new. It's a brand new example. Okay, so this is what we have. We can enter this in any order that we want, but you know, really, literally any order we want. Let's just lay out the structure first. I mean, that would be a good reference to put the ones first, just like, no, you don't really need to build it, you know, like we generated the graph on the, but you could build it from anywhere, basically. In fact, true to what I'm saying, I'm gonna do exactly that. Let's say, you know, even exaggerating a little bit, that we start there, and then we go, because we're gonna start anywhere, really. But the only thing is follow the power flow. In other words, because that is has an influence in the calculations. If you get one of those signs incorrectly, then there's very difficult to fix. So here we have a 1 and 2. 1, this would be this the 0 in here, and you could immediately choose this and then build the other one right here. See the 0. See, let's get not lost here. This part is the one at the top. And we have the 0 in here. Sorry, we need the 1 node down here, and then we need the I element. So we need over here. See, we need it like this. Yeah, there we go. And then another 0 and a 1. And then we have this 1 over here. And then you have the C and the R. And then you have it like that. Yeah. So we're done here. Like I said, it really doesn't matter how you started. I'm just gonna put it exactly like in the paper. And then this other one, the I element is placed over here. See this right there. Okay. And I think we have just a couple of more steps to finish this. This one is in here, this. And you have the, like this, yeah. And I believe, see, we could move this a little bit in here. And move the whole graph to the left so that we did it too fast. There we go. Okay, so we only need this SF element and we are done. This element SF in here. This is the one with velocity 0. See, here there is, actually this is good that it happened because you see there is an error in here, this 1. If you want to analyze this, say explain what this is. Explain. You know, I have this red. If you click in there to explain, it will give you a message. I believe it's down here. See, can't locate from element for bond. It says this is not right. The reason that is not correct is because I messed it up, that instead of a 1, I put, instead of an I put a 1. So we need to make that correction here. Let's do the delete. And in here you have to put this 1. So you put the 1 over here and then from here to here, and you have finished the bone graft model of this. So that's how we enter it into the ChemG software. Okay, so I'll just put both of them side by side so you can see the actual bone graft model that we entered on ChemG and the one that we have in our notes.